All right. Good afternoon, everyone. So my name is Alberni-Clayoquot, and I work with the Tofino Community Food Initiative. And Tofino Community Food Initiative operates on the unceded, ancestral, and traditional territories of the Clayoquot First Nations. And this is where I'm joining from today. So I'd like to invite anyone participating in this workshop or who's watching this recording to reflect on which territories that you're joining from today, and also just acknowledge the impact that colonization has had on Indigenous food sovereignty, ways of knowing, and access to land. And that when we refer to agriculture or gardening, this encompasses a really narrow view of food cultivation that does not reflect the diversity of cultural knowledge within our region. So for today, we're joined by Connie Kuramato of Gardens on the Go for a workshop on building soil, irrigation, and pest management. This workshop has been designed for our collective group of community gardeners that are championing growing initiatives in 10 coastal communities within the Alberni-Clayoquot Regional District, and is the result of topics that were identified during virtual gatherings we had this past winter, which were supported by a Plan H Community Connectedness Grant. And this particular workshop is part of a project called Growing Resilient Coastal Gardens, which is a partnership between Tofino Community Food Initiative and the Alberni-Clayoquot Regional District, and has generously been funded by the Clayoquot Biosphere Trust. So with that, I'll pass it over to you, Connie, and we'll get right into the workshop.
Thanks, Ellen. And I am so pleased to be here today. Hopefully the background noise of them logging across the street from me doesn't interfere. And if it does, someone let me know and I can close the window because I don't really know how the sound travels through there. But yeah, today we're going to talk about the basic topics of how to get a garden started and the important things that you need to focus on. And really, all three of the topics that I've been asked to speak about today are really strongly interrelated. They can't be separated from one another, really. And so what I'm going to do is I'm going to share my screen. I have a couple of PowerPoint presentations. Also, if you know how to use the chat, it's at the bottom of your screen. And I am happy to answer questions. If you click on the chat and type your question in, that's the easiest way to ask a question. And then I can read it. And if I don't get to your question right away, it's because I know I'm going to be covering that very soon, but I do like to answer questions as they come up, because I know as a student, if I didn't get my question answered, it would just go around and round in my head. And I just couldn't concentrate on anything else until my question was answered. So please feel free to put it in the chat and then I'll try to answer. So with that, I'm going to start with my very favorite topic, which is soil. So soil is something we have really little of on Vancouver Island, except in isolated pockets. So Cowichan Valley, the Alberni Valley, the Comox Valley actually has soil. Many other places on Vancouver Island doesn't really have a tremendous amount of soil. It's nothing like the prairies where the soil is meters and meters and meters deep. We just don't have that. And so we have to build our own soil. And so we're going to talk about some of the important aspects of that and how to do that. So here's a beautiful pile of soil, and gardeners are the only ones I know that will stand around a truck of manure and go, ooh, ah, oh, wonderful. you know, and I've witnessed it many times, and it is really important. But the soil is more than dirt. Soil is really complex, and it's made up of all these different factors of, there's the sand, silt, or clay, which we're going to take a closer look at, which is parent material, and different parent materials will weather down to different soil textures. And then over time, of course, so that's a factor. Climate plays a difference, say for people on the West Coast, the water that falls from the sky is a huge factor in how soil works. So that has an influence. The whole topography, whether it's flat or sloped, and then there's organisms that really do the bulk of the work of building soil. So, you know, I so often see or hear people go, well, I'm going to put in a garden, so I need to get the area ready before I put in plants. But really, one of the best ways to start a garden is to put in plants that will withstand almost any conditions, and then they will help you build soil. So we're going to talk a lot about things like that. So what happens with the soil that you do have, or even the soil that you buy, is that it is generally made up of a bunch of different sizes of particles. And the names for these particles are generally gravel, sand, silt, and clay. And you can see the difference in this picture, where gravel, of course, is these huge particles, and sand are these smaller particles. Silt you can barely see, and clay is absolutely invisible at this particular scale. So you can't see an individual clay particle at this scale. So they're very, very tiny. And so the makeup of your soil will affect a lot of different things. Because first of all, if you have big particles, they're not going to pack so tightly. They're going to, just by their very nature and physics, make a lot of air spaces in between them. Whereas clay, because they're so small, they really pack tightly. And we did soil tests on the West Coast a number of times, and it was absolutely fascinating how much different the soil was, even on one side of the Essaouista Peninsula to the other side of the Essaouista Peninsula. There was more sand in one, there was more clay in the other. So the inlet side actually had more clay, and the ocean side actually had more sand. And so it's kind of interesting that even in that small area, the results we were getting from our soil tests were quite a bit different one person to the other. So it's always worth doing some sort of soil test just to get a baseline of figuring out what you're dealing with. So here's some other illustrations just to show you. And this one on the left, on my left, shows you how things pack. And you can see you can barely perceive any air spaces with clay. With silt, you can perceive some air spaces. And with sand, you can perceive a lot of air spaces. And this really affects water infiltration. And that is how quickly the water is going to flow through your soil. And with sand, the water will go into your soil and will just keep going. It will just flow right through, taking with it any nutrients that it pulls along the way. Some nutrients are very soluble. So sand itself holds very little nutrients, and any nutrients that you add to it will flow through very quickly. And so end up in the inlet and end up in the ocean, which really, if we're adding even manures or organic fertilizers, we really don't want that to happen. We don't want our fertilizers to end up in the water bodies. So sand is a difficult material to deal with. Silt is kind of in the middle. It holds some nutrients. It has medium water holding capacity. So it's kind of a bit more ideal. And when we think about history, a lot of the great civilizations were built on deltas that have silt in them, a lot of silt in them, because it's washed down from the river. So say even the mouth of Kennedy River probably has some really good quality silt that has got some nutrients in it. Clay, on the other hand, it has, it's just like any of these soil textures, has its advantages and disadvantages, in that clay is a lovely texture for holding nutrients. It has an electrical charge. It's washed, it's weathered down from materials that have high electrical charges. And those high electrical charges really hold on to any nutrients that you put into the soil. The disadvantage of clay is that the particles packed so tightly that water has a hard time infiltrating. And so water will puddle on the surface rather than infiltrate. And if the water doesn't infiltrate at all, what happens is it'll either run off, causing erosion, or it will evaporate. So there's all these different soil textures. Usually soil is a combination of different soil textures. And so it's kind of good to know what you're starting with. So there's lots of different information on the internet. We can't go through it all today, but it's really worthwhile to do some of these basic soil tests to see what you're starting with. It's also important if you're buying soil to see what you're getting. So really important to know how to do these tests. And there's a simple test called the ribbon test that's very quick, but it's hard to be as accurate with it as the jar test. So the ribbon test is just, you take a handful of soil that's moist and you squeeze it in your hand, as in this corner picture. And when you open your hand, if it just falls apart again, then your soil is probably got a lot of sand in it. If you squeeze that soil and then open your hand and the ball stays together, it's probably got some silt or some loam in it. So that's really much better because that is kind of a nice balance between the two. But then if you take that ball and you try to roll it between your two hands, as shown in this picture, and it actually rolls into a ribbon, well, you have clay. So really nice to know where you're starting, because especially if you're planting trees, shrubs, woody perennial plants, it's really important, because if a plant likes good drainage, it might not do so good in pure sand, in pure clay. But if your plant likes wet feet, then it might not do so good in sand. So sometimes it's beneficial to know your soil texture so that you know what you're starting with, and you realize what you have to do to your soil, that you have to do something to your soil before you plant these permanent plants, or else they'll always struggle. And as we'll talk about sort of again and again and again in this, and I know that a lot of even old time gardeners have a hard time believing this, but it's been shown over and over again in science that it's generally a plant that is stressed in some way that attracts insects and diseases. So as our job as gardeners is to figure out, what is that stress? And earlier we were talking a little bit about flea beetles on tomatoes. And the stress I can perceive just sometimes stress can't be avoided. We all know that even in our lives. And the stress that I could perceive there is, it's just never warm enough on the West Coast for tomatoes to be happy. So sometimes it's hard to avoid that stress. And so we have to do as well as we can to compensate for that stress. So that's kind of the whole thing starts with the soil. Well, I'm just going to go back. Sorry, I want to make one more point. This is a jar test for soil. And if you Google jar test for soil type, there's even some worksheets. And maybe if I get a chance, I'll send them off to you, Helene, where there's some worksheets that will walk you through these soil tests, where you just put soil in a jar, you fill it about 1/3 full of soil, you add water, you add some soap, a couple tablespoons of soap. I usually use the straighter the sides jar that the jar has, the better. So then you add the soil, you add the soap, you add water, and then you shake it up really well and you let it sit. And the soil, the sand being the heaviest, will sit on the bottom. The silt will collect on top of that, and then the clay will collect on top of that. So then you can see your percentages of sand, silt, and clay. Then what we do is we use the soil texture triangle, and we mark the percentage of sand is on the bottom, and I'm sorry for this, is a little unclear. The printing is a little unclear on it, but there's percentages all along the bottom. So say your soil is 30% sand. So here's the 30. You make a mark here, and then you make a line with pencil right across the whole triangle. And then say your percentage of silt is around 30. And this is never an exact science. So don't worry about every little that this is, it's 31 instead of 30, just approximate it and draw your line down from 30. And then clay, say your soil is around 30 or 40 to make up for it, but it'll always add up to 100. But even if you're around 30, you'll get a pretty accurate reading. And so then you want to go across with that. And where those 3 lines intersect will be someplace in this triangle. Sometimes they intersect on a point. Sometimes they'll actually make another triangle in the middle of this triangle or in the sides of this triangle. But wherever that falls will tell you what your soil is as far as sand, silt, clay, or loam. Now the ideal is kind of a medium loam. It's right in this portion here. And you can see it sort of in the bottom middle. And that is approximately 33% of each of those 3 materials. And that's ideal. You can plant right away into a medium loam. If you have a loamy soil at all, chances are you won't have to worry about water infiltration. You won't have to worry too much about nutrient holding capacity. And so then you can go ahead and plant your more permanent plants in there pretty quickly. And your soil will always need organic matter for a bunch of different reasons, but and you can never change your inherent soil texture. That is, you can never change that. What you can do by adding organic matter is you can compensate for the deficiencies of the different types of soil texture. But what you can't do is you can't change your inherent soil texture. You can change your soil structure. And your soil structure is a combination of your soil texture and a lot of those other factors that we looked at an earlier slide. So here's another illustration about here's sandy soil, just runs through your hand. This is actually what I started with when I started my garden. It looks more like this loam, even though it's not technically a loam structure. But now that I've changed texture, but now that I've changed the structure for it, it looks a lot like more like loam. And of course, clay, you can make clay pots out of to put your plants in. So it's an extreme texture. So the whole big deal about soil texture is part of it, and soil structure is soil pores. So there's chemical factors, there's physical factors, and but soil cannot support life if it will not hold both water and air. And it won't hold microbes needed for nutrient delivery. Plants will struggle in it, either because they don't have enough air in their roots, or water becomes scarce very quickly. So what soil needs is both micropores and macropores. And the macropores are, just like they say, big. Macro means big. So the macropores are big pores in the soil. They're big gaps in the soil. And those are the pores that hold air. And the micropore, they also carry water, but they hold air. And the micropores also hold air, and they provide air movement in the soil, but they can also hold air. They provide air movement. So macropores provide water movement, micropores provide air movement. And they're both important. It's important that you have both in your soil. So micropores hold water, macropores hold air. And here's a great illustration where you've got these little blue dots of water, and close up you can see them. Water has adhesive and cohesive properties. So that means that water's adhesive properties causes it to stick to the soil. So it adheres to solid surfaces. And we know that because when we wash our dishes, they're not immediately dry. When we wash our clothes, they're not immediately dry. So the adhesive properties of water are actually stronger than gravity. So water will hold on to soil if it has a place to stick to. Then also there's the cohesive properties of water, which means water will stick to itself. And you can see that in this illustration where the water molecules are actually sticking to each other as well as sticking to the soil. So that demonstrates the adhesive and cohesive properties of water. So when we look at this bigger illustration, we can see that the soil is really complex. It's a lot more complex than we realize because there are all these different particles. They all have different electrical charges. So they all have the ability to hold more or less nutrients, more or less soil. The more surface area there is, the more places there are for the water to cling to. And so there's all kinds of different combinations of soil, air, and water that can happen in your soil. But the ideal is if it holds water and air in the same, approximately the same quantities, which again is loam. And why this is important is because most of the organisms that are beneficial for our soil and beneficial for plant growths in our soil like to have both water and air in their environment. So most of the most beneficial organisms, there are a few exceptions, but most of the most beneficial organisms will need that air in the soil to be able to breathe, and also will need water because water is just crucial for all of life. And so that is really an important thing. the microbes perform so many different functions in the soil. They say in this little picture, you can see where this might have been just this sandy soil, and this is probably what I started with in my garden. And then once you get good quantities of microbes, so by keeping the sand moist enough somehow, and we'll talk about the methods to do that, by keeping the soil moist somehow, and by including food for the microbes in our soil, then what happens is the microbes start to grow and multiply. And when they do, what happens is that they excrete things that help hold soil particles together. So the soil particles become loose aggregates. They're not held together tight like clay, but what they are held together is in these loose aggregates that prevent soil erosion, yet allow water infiltration and hold more nutrients. So we have a question. Yeah, thank you for, please do include, go to your chat if you have questions, and feel free to ask any questions. Thanks, Helene. So what happens if you don't have good infiltration? Here we have this aggregated soil. So here's these aggregates of soil. So aggregates are just clumps, basically, and they're loose clumps of soil. And if we have a lot of them in our soil, what happens is that water can infiltrate. It does stick to all these different aggregates, but some of it does filter into the lower levels, and that's great because it replenishes our water tables, and also it puts water where it can't run off. So it stores water deeper in the soil. And if water is stored deeper in the soil, then what will happen is the plant's roots will go deeper looking for that water. And when they do that, it creates more drought resistant plants, because the plants will have deep, extensive root systems that can have a bigger surface area and ability to search out water and to come across water and to deliver it to the rest of the plant. However, if we have a situation like on the right, where you have aggregates that are broken down, so this could be a result of a couple of different things where you see this water running off. It could be a result of a lot of clay in your soil, because clay is really fine particles. And so it could be a result of a lot of clay in your soil that is packing really tight. Or it could be a result of having different kind of soil aggregates, like decent soil aggregates, but with a lot of impact on those soil aggregates that again breaks them down into smaller pieces. So what could that impact be? That impact could be walking on soils too much heavy weight. It could be heavy rain, like the tremendous rains that everybody has been getting lately. Water has been falling in more dramatic events. We get the same amount of rainfall, but the rain is falling heavier. And that's been a studied, observed, proven fact pretty well all around the world, where we're getting more extreme weather events. So we're getting more extreme rainfalls instead of, lighter rain over a longer period of time, amounting to the same amount. So any kind of banging on the soil, it could be from too much tilling. It could be from too much working the soil, because that will break these aggregates down into smaller pieces. The smaller pieces, of course, float to the top. And the smaller pieces then will tend to, because smaller particles do that, they'll tend to compact. And once they compact, water the water delivery rate is often at a higher rate than what the soil can absorb. And so if the soil can't absorb it, the water is just going to run right off. So you're losing the water, and quite often it will take some of these smaller particles with it because they're small, they're light, they float. And so you're actually, after working so hard to build soil, you're actually losing soil. So we want to prevent this crustification at all costs. So how do we do that? Well, organic matter does a lot of things for your soil. And one of them is to hold nutrients. So here's a soil particle, and it's probably more like a soil aggregate, although it could be a clay particle. Oh, it must be a clay particle, actually, because it's got all negative charges. So this is a clay particle, of course, magnified many, many, many times. And so you can see that clay in the northern hemisphere, well, in the temperate zones, temperate zone clay actually is negatively charged. So there's all these negative charges that are inherent in that clay particle. What happens is that nutrients, a lot of the major nutrients, not all of them, but a lot of the major nutrients are positively charged. And so just like a magnet, the positively charged particles like potassium, calcium, magnesium, and they will stick to this soil particle because of magnetism. So that little clay particle is holding on to all these nutrients, and the nutrients are only released when it gets a signal basically from the root hair. What happens during photosynthesis and respiration is during photosynthesis, a plant builds carbohydrates. During respiration, the plant breaks them down for energy, just like our eating and digestion. If we can't digest our food, then we won't have any energy. We could be eating food, not digesting it at all. It could be going right through us, and we don't get the nutrients from it. And that's what can happen in soil as well. And plants, when they are digesting their nutrients, part of that process is to break the carbohydrates back down. And so here we have a chemical formula where you have water, and CO2 is the byproduct of respiration. It forms something called carbonic acid. And carbonic acid, all acids give off hydrogen. That's what they do. That's the definition of an acid, is that it pushes out hydrogen like crazy. It dumps its hydrogen right away. Well, hydrogen also has a really strong positive charge. And what it will do is it will actually push the other nutrients off this soil particle, make it available for the root hair to absorb. So this is an ingenious system, because as the metabolism of the plant speeds up, which happens when it's warmer, which is our growing season, as the metabolism of the plant speeds up, it will respire at a quicker rate, it'll give off more hydrogen, and it'll bump off more nutrients. When the plant's colder and its metabolism is slower, then it doesn't give off as much hydrogen. And the beauty of that is that all these nutrients will just stay locked in your soil. So water alone can't knock the nutrients off of nutrients that are stuck tightly onto clay particles. So as you might know, if you've been gardening for a little while, or as you might not know if you haven't been, Nitrogen, phosphorus, potassium are pretty well the macronutrients, and they're the ones that are needed in the highest quantity. And as you can see here, we have some of those missing. So where does nitrogen come in? Does nitrogen not stick to anything? The beauty of the system is that nitrogen tends to be a negatively charged particle. It won't stick on clay, but organic matter has both negatively charged, negative charges and positive charges. So what happens when we add organic matter to our soil is that we're increasing our nutrient holding capacity like crazy, because not only is there more surface area, organic matter particles are even bigger than the biggest sand, silt, and clay. They're big and they have both positive and negative charges. And so soil with organic matter will hold nutrients far better than soil that has no organic matter in it. When you have organic matter in your soil, also what happens is that earthworms tend to be attracted to the bacteria that's breaking down the organic matter. And earthworms will burrow in the soil and they'll ingest soil, and they'll combine that. They'll eat, they actually eat a little bit of grit, and they eat the bacteria and the microbes, and then they'll excrete it. And when they excrete it, it actually, their excrement is one of the things that actually holds all those soil particles together, again, in those loose aggregates. And their excrement also is really full of nutrients. So worms perform a few different functions in the soil. For one, if you have that crustification here, the worms burrowing through will help with the infiltration so that water doesn't sit on the surface of the soil and run off, that it will actually infiltrate through there and feed all the microbes and make them all happy. And yet the whole idea of infiltration is that it's, as the water goes through these tunnels and through this soil, it not only moistens the soil, and some of the water will stick because of adhesion and cohesion, it actually will flow through a bit too, and that flow through action pulls fresh air from the air into the soil, because the little microbes in there really need fresh air. They don't really want stale air to breathe. None of us like stale air to breathe. And so that whole action of infiltration provides the microbial life of your soil with both water and air. And worms assist it by not only eating microbes and making tunnels, but their excrement provides more glue to hold things together lightly, more nutrients. So worms are a really good thing, and they're attracted to areas that have organic matter in them. Plant roots also contribute to the aggregation and development of macropores, because as they're pushing through the soil, they can actually, some plants are tough enough to be able to push the tightest packed soil particles apart. And we see that with a lot of common weeds, like dock, buttercups. There's so many weeds that grow in really compacted soil. They're the first ones that appear in a gravel driveway, in a hard pan driveway. There's always those weeds that, and they're there to help the soil heal, basically. Weeds are there to provide something that the soil hasn't got. And that's the way of this earth, is that weeds are provided to fix the soil with whatever problem it has. The trouble is that sometimes it's a slow process and we get impatient, that's all. But what will happen is that things like, well, even daikon radish, if you have a really compacted soil, Mas Fukuoka from the Three Straw Revolution, what he did is he planted daikon radish. He would do that in his seed balls and throw the seed balls out in really compacted soil. And the radish, the daikon radish, has enough strength in it to actually push through really compacted soils, providing these air spaces. So you can either leave it to rot, or even if you pull the radish later, it's going to leave water spaces, it's going to leave air spaces, it's going to leave places for the water to infiltrate through. Not only that, when a root penetrates into the soil like this, there's not only spaces that it makes, but the root is always excreting things. It's always giving off exudates, just like our skin sweats or skin cells are sloughing off. The same thing happens with roots. And so what's going to happen if there's food is there's going to be microbes. So any kind of plant, your soil is actually better off covered with weeds that are feeding microbes in your soil than it is if it's bare. So weeds are really a gift to the microbes because they are feeding those microbes that will then help to change the nutrient content and the aggregate ability of your soil. So what's our role as gardeners? Really, our primary role and our primary goal is to protect and feed those microbes. Microbes provide so many different services. The microbes will provide food for plants. They're the food delivery system. They will provide help to aggregate soil, to provide those air spaces, to provide the microbes with air. They will also, in many cases, kill off disease organisms because they're dependent, microbes are dependent on the plants for their carbs. Most microbes, I can't say all, most microbes cannot actually get their carbohydrates any other way except from either broken down plant material or the live exudates from the plants. I see there's maybe a question. When do you dig in broad beans to help soil? I don't dig anything in if I can avoid it. What I do is I chop it and I let it sit on top, because most of and I'll get to the when in a minute, but most of the microbes that are really active in breaking down things are aerobic microbes, and they break things down the most efficiently. Anaerobic microbes are not as efficient. Many of the nutrients are lost to the air when anaerobic microbes break them down. But when aerobic microbes break down nutrients, they're very efficient. So they don't lose any to the air, or very little to the air. And so by just letting them decompose on the surface, you get mulch, and we'll talk about the benefits of mulch. And also they're broken down in a more effective way. The when is basically whenever you want, but they will provide more nutrients to the soil when they are, before they flower, or just when they're starting to flower. That's when the plant itself will have most nutrients, because it takes a lot of energy for a plant to switch from vegetative to reproductive. And so before it's used up that energy to switch to reproductive, or before that's visible would be ideal. Once it's visible, it's already spent a lot of energy on it. So younger is actually better, but you sort of want to maximize the amount of plant material as well. So it's kind of a balance. So I would say when it just looks like it's going to start to flower would be the ideal for providing the ideal amount of nutrients. Now, you know, saying that you can just chop and drop them is one thing, but also the smaller the pieces, the quicker the whole thing is going to decompose because there's more surface area for the bacteria to colonize. So if you want it to break down quickly, you can chop it up small, run a lawnmower over. I know a lawnmower is not a common animal in Tofino. Because there's not many lawns. You can run the weed eater over it, a hedge trimmer, chop it up with a machete, anything you want to do to make the pieces smaller. If you want it to protect your soil for longer as a mulch, then just lay it down as it is. Another question. So you dig up the roots and chop to? No, I leave the roots. I would just leave the roots to decompose. Without the top, they'll actually decompose really quickly. And what happens is that they'll continue to feed the microbes as they break down in there. So I would, you know, because they're close enough, most of them are close enough to the surface. Also, as the roots rot, it's going to create more tunnels for infiltration. So I would leave, I usually cut plants off if I'm harvesting, I usually cut them off at the soil surface, and then they continue to feed the microbes in the soil. So hopefully that answers your question. So tilling the soil really creates lots of problems. And hey, I used to run a rototiller business. I used to have a Troy 8 horsepower rototiller, and I used to till up people's gardens. And you know, sometimes you kind of got to do it. If you're starting from scratch, if you have lots of material and a big area to do, sometimes you have to till. But to repeatedly till totally destroys the life in the soil. It's like you're turning, it's like an apocalypse for microbes when you till. You're breaking up all those fungal nets that the soil mycorrhizae took so long to establish. You're taking the microbes that like living on the surface of the soil and you're pushing them underneath the soil. You're taking the microbes that like living deep in the soil and you're pushing them on top. And like microbes arrange themselves in the soil by how much air they like to breathe, or in some cases, it's not what they like, it's what they need to live. And so many people see good results when they first till because you're putting a lot of oxygen in your soil. It's breaking down any organic matter that you have tilled into your soil, and it decomposes very quickly. So you get a really dramatic kind of effect. But what happens is that also burns the soil out more quickly because there's too much oxygen in the soil. It will actually oxidize some of your nutrients. So they actually, low level combustion is what happens, and hardly perceivable, but it's happening. And so we don't want to do that. And you know, the fungal mycorrhizae that develops in an undisturbed garden over time, I mean, there's always, you have to dig a hole to stick a plant in. You know, you have to kind of loosen up the soil a little bit, but whole scale tilling really destroys soil structure. So you're creating a lot of smaller particles that will float to the top and then cause water to run off it because they compact. You're breaking up all the mycorrhizae, you're destroying the habitat of all these beneficial microbes, and you actually are killing worms as well. So if you can avoid tilling, it's the best. For containers, no, I don't empty the containers at the end, but I'll tell you what I do that works really good for containers is because I grow my tomatoes in big containers because it's warmer. And so it's a good suggestion for the West Coast. And what I'll do is I'll actually fill my big containers at least half full of organic matter. So I just put anything, buttercups. I don't use bindweed, but I do use buttercups. I do use dock. I do use grass clippings. I do use seaweed. I do use wood chips. I do use any kind of manure. And it can be rough. It doesn't have to be decomposed. And I fill half of my containers with that. And then the other half, I use a combination of half compost and half some kind of soil, like potting soil that I've bought, or soil from an area from my garden. But I mix the two together. And that works really good. It works really good. And it does shrink as it composts. And so as it shrinks, I just add more organic matter or more compost on the top. So every year it is getting a lot of new stuff, but not 100%, because to dump all those containers and replace it with soil is just too much. You know, it just, especially if you're buying bagged soil. I mean, what's the carbon footprint of transporting all that soil? So that's what I do. And I find by leaving the containers in place too, it gives the worms a chance to really colonize in there too. So it's like I've got a little worm farm in the bottom of all my containers. So roots, actually, this is a beetroot. In ideal soil, a beetroot will actually go 300 centimeters deep into the soil in ideal soil. When you start to till too much, what happens is you create a compacted layer that's called a plow pan. And the plow pan actually can limit the amount of root growth because it compacts the soil. It will also limit the amount of air and water infiltration. So try not to till if you don't have to. Try to just keep adding organic matter on top. The mycorrhizae, this is kind of a picture of the mycorrhizae. And not only do the mycorrhizae secrete stuff called glomalin that improves soil structure, so holds those pieces of soil all together so they don't wash away, it also searches for more water and nutrients. And so I like to kind of call it extendo root because that's what it does. I tried cover crops last year. Amelia is saying, I tried cover crops last year at nitrogen fixing soil stability support. It suggested turning the cover crops before spring planting. Any kind of, and that's a bit old school. We're going to talk a bit about cover crops and how to deal with them. So if you can just kind of be patient, but the whole chop and drop method is the one that I really advocate. So what you do is you just chop them down and then cover with more organic matter. And you're basically composting them in place, but you don't actually have to turn them under. You can turn them into a mulch instead of actually incorporating them in the soil with rototilling. So feeding your microbes. What do microbes like to eat? Organic matter. If you increase the organic matter in the soil by 1%, from 1% to 5%, you'll increase the water holding capacity by about 5 times without limiting the air holding capacity, because organic matter holds water and air in approximately the same proportion, the ideal proportions. So by adding organic matter, you're really increasing the water holding capacity of your soil. After about 5%, it sort of levels off where it's not as dramatic of an increase, but you will, at 5% organic matter, you'll be holding a nice amount of water in your soil, and it'll lessen your need for irrigation. And that is where it starts to integrate with irrigation, is that the more organic matter that you add, the more water your soil will hold, because organic matter is a real surfaced particle. And so all those surfaces will hold water. Water will cling to all those different surfaces. And here you can see, again, this picture where the soil minerals are this smooth surface. So yeah, there's some places for water to cling to, of course, but organic matter is a jagged surface. It's got lots of different surfaces. And so, oh, sorry, I should have turned this off. So what happens is that there's lots of places for water to cling to. So that really improves your water holding capacity. And so what do microbes eat? Organic matter. Husks, wood, straw, dry plant material, green plant material, animal manure, kitchen scraps, all the seaweed, you know, all those kinds of things. Weeds are an excellent source of organic matter, and they're delivered right to our doorstep. So it's quite wonderful. So of course, compost is a wonderful addition to any garden. Nice compost pile here. This is a nice worm bin. Here's a bokashi bin. And if you don't know what bokashi is, B-O-K-A-S-H-I, look it up, because it's a great way to compost in your kitchen, and you can compost meat and dairy. So when you look at compost under an electron microscope, it's really complex, because it's supporting all this different microbial growth. And soil itself is this really dynamic thing. Here's the pie chart. And you can see in this pie chart that there's some ranges here. It's not just a static pie chart. There's living organisms in decent soil, and they're around 5%. There's fresh residue that's either someone's chopped and dropped weeds, or leaves are falling from trees, or oops, or whatever organic matter. Insects are falling from the sky when they die, and you know, adding to organic matter. But then you have these two biggest compositions. Decomposing organic matter, actively decomposing, is 33 to 50%. And that changes day to day by the amount of moisture, by the amount of heat, because with heat, the organisms are more active. And so more of the matter will become decomposed. When it cools down, it'll drop down, because there's less organisms that are active at cooler temperatures. And so this is a big range between the two. And then we have stabilized organic matter, and that is actually humus. So that is actually good quality soil. And humus is, when they say stabilized, it just means it's been eaten so many times by so many different things that original organic matter, you can't distinguish it from anything that it was originally at all. So that's what finished compost is, basically, is stabilized organic matter, and it will make up 33 to 50% of the soil. So think kitchen sponge. Organic matter is like a sponge. It holds both water and air in about the same quantities, and that is a diverse ecosystem. Our most diverse ecosystems on the planet are where there's both sufficient water and sufficient air. And it's no different in the soil. When there's sufficient water and there's sufficient air and sufficient food, then you get a very rich atmosphere with a diverse population of microbes. And the more diverse population of microbes that you have in your soil, the more job descriptions you have. So it's just like humans. If you have a lot of humans in one place, there's a lot of different job descriptions. There's a lot of different jobs available for people. If you have a limited amount of humans, there's not as many different kinds of people there, and there's not as many different job descriptions. And it's the same in the soil. So what some of the job descriptions are for some of the microorganisms, maybe some will eat one kind of soil disease, soil-borne disease, another will eat another kind of soil-borne disease. Another will decompose wood, another will decompose citrus peels even. When I was in Hawaii, citrus peels had no trouble breaking down, and it wasn't just the heat. It was also that the microbes in that ecosystem, because there were oranges growing there, the microbes were available that break down citrus. So the more diversity, the more, so if we could import some compost from Hawaii and inoculate our piles with it, we would have more, our citrus peels would break down more quickly. I don't eat citrus anymore because it's got too much of a carbon footprint, but that's another story. Are there any downsides to adding unfinished compost to your beds? It depends on where you add it. So if you are building a sheet mulch garden or a lasagna bed garden where you're layering organic matter, if you layer your partially finished compost on the bottom layer right above the area, so I just chop down grass or weeds, or I've even done it on top of broom bushes. I've just chopped them right down when they were in bloom, and then laid the organic, they had no weed seeds on it, and laid it down, chopped it up a bit, laid it down, put a bunch of organic matter on top of it, including partially finished compost, and then layer more organic matter on top of that, then there's no harm in using partially finished compost. So if you use it in one of your bottom layers in a sheet mulch garden, and we're going to talk more about that, that's a good place to use it. So in general, the biodiversity tends to increase when there's enough moisture and there's enough air. And this is just a soil profile. And this is the most active part, is right on the top. And so this is the way nature has built soil from the beginning of time, is that organic matter falls on the surface, the microbes break it down and build soil. So it's only us humans that have wanted to dig organic matter in. Nature just deposits it on the surface. So any of your organic matter just gets laid on the surface because that's the most efficient place for it. And it also protects the soil from erosion, protects the soil from extremes of temperature, feeds the microbes on a very slow release kind of way. And so less nutrients are lost from the organic matter that you do apply. So mulching is really one of the very best things you can do for your garden. And there's lots of people that will say, oh, well, I would mulch, but it increases the slugs and snails. And that may be quite true. However, slugs and snails really prefer eating mulch, so partially decomposed material, to healthy plants. And sometimes when I say this to people, they get almost insulted. They go, well, my plants are healthy. And it's hard to tell with the human eye whether a plant is healthy or not. It really, if you do Brix readings, it's a little bit easier. So, which is a whole other class. It's just measuring the carbohydrates in them. If you do chromatography on a plant, you can tell. But with the human eye, you have no way of telling if your plant is healthy. You really don't. And a plant could be experiencing nutritional stress, either because there's not enough nutrients in your soil or because there is no nutrient delivery system. So your microbial populations aren't there at sufficient numbers. And so, or the other stresses that plants experience are temperature stress, drought stress, wind stress. So any of those stresses. So the other role of gardeners is to eliminate plant stress. And that involves getting to know each plant that you're planting and what it likes and what it doesn't like. It also involves building your soil so that you have a storehouse of nutrients, a storehouse of lots of diversity of microbes in your soil to deliver the different nutrients to your plants as they need it. And so it's not applying mulch that is causing the slugs and snails to attack your plants. What it is your plants are unhappy for some reason, and it's our job as gardeners to figure out why. Again, sometimes stress can't be avoided. When you first transplant a plant, it's going to be under stress. We can alleviate a little bit of stress by using things like seaweed fertilizers, because seaweeds have things in them that prevent that sort of mitigate plant stress. Other things that mitigate plant stress a little bit are horsetail tea, nettle tea, comfrey tea. All those plants have minerals that help alleviate plant stress. So, and then adjusting the environmental conditions. Sometimes we just can't grow certain things in certain soils at certain times of the year, and that without having them be stressed. So we have to accept a certain amount of insect damage sometimes, because we as gardeners are pushing our will on this plant and causing it stress. We're wanting to grow a broccoli in the middle of winter, and some of them are adapted to that and some of them are not. We're wanting to grow peppers, say, even on this side of the island, it's difficult to grow peppers because it's just not warm enough for them. I mean, you can, but they're always under a little bit of stress. And so that's when insects attack, because an insect's job is to remove a stressed plant from the ecosystem so that it doesn't reproduce. So one of the ways I find that alleviates a lot of different types of stress is mulch. And if there's a few slugs and snails to show me which plants are stressed, to remind me that maybe this plant isn't getting everything that it needs, then so be it. But it still eliminates a lot of different types of stress, and so it's worth considering. So mulch will keep down the weeds, which will keep them from competing with your plants. It'll hold moisture. It will keep the soil from compacting, and it'll hold on. It'll help to hold on to more of that rain that falls from the sky, more of your irrigation water, and it will also moderate soil temperatures. Of course, if your soil does heat up too much, it's going to evaporate more water from it. If it cools down too much and freezes, you can have plants' roots heave right out of the ground. You can have a situation where plants' roots get damaged. Plants will come out of dormancy too soon and then get frozen. So mulch really does a lot of things, and it feeds the microbes, and which in turn feeds your plants and builds up that soil structure so that you have less stress to begin with for your plants. So here's a great chart of with mulch and without mulch. And now probably in Tofino, your soil will never, your soil will never get this hot. In Port Alberni, I bet it could. So once it's mulched, if the temperatures are, very warm, without mulch, your soil can actually reach up to above 50 degrees Celsius. That's going to kill off a bunch of microbes. A bunch of water is going to evaporate from it. It's really not a good situation. Also, the humidity at that high temperature is so low that plant stomata will actually close to conserve moisture, and the plant shuts down. It won't photosynthesize, so it won't take up nutrients. That transpirational pull is what pulls up nutrients, and the plant can't do it because the stomata are closed down, there's no transpiration, then it's going to be lacking, especially some of the more immobile nutrients like calcium and phosphorus are very difficult for the plant to take up without active transpiration. However, if the soil is somewhat moderated, then the plant can continue to do its work. So what are some good mulching materials? Wood chips are great because slugs don't seem to really, it's not that it totally repels them, but they don't seem to like it so much. It's a myth that wood chips rob the nitrogen of soil. There's been recent tests done on this theory, and the soil scientist who did these tests said that the nitrogen was tied up for a matter of hours, really. And so wood chips are a really great mulch. If you're still concerned about using wood chips and it's going to tie up the nitrogen, or if your soil is really poor and you see some signs of nitrogen deficiency, like the oldest leaves turning yellow, just add a little bit of fish fertilizer or a little bit of nitrogen fertilizer, a little bit of liquid fertilizer, and that will go away. And eventually those wood chips will break down to a really nice fungally dominated soil, which is really good. Cedar is absolutely fine. And that's another myth that cedar has all these oils and it's going to kill your microbes and it's going to kill your plants. I can't tell you how many times I have used cedar for wood chips, and every time people have said, oh, you're going to kill your garden, and it never has. I even tried it again very recently. I put it around my fence, hoping to kill the tall grass around my fence, and the grass grew even taller because the cedar wood chips were holding in the moisture. So there was one incident with squash plants that I mulched with cedar, and the squash plants didn't grow really well, but the soil was so poor that once I added a little bit of compost to it, it just turned it around and it was fine. Straw is another one. It's hard to get unsprayed straw, unfortunately. I was lucky I found some oat straw that was unsprayed, but you can ask around and try to get some because it's a great mulching material. But anything that's organic, leaves, even pine needles, the whole thing about acidic, alkaline in an organic garden is just not as important as it is in a garden that is managed with chemical fertilizers. Paper, shredded paper is a great mulch. You can worry about the dyes and you can worry about the colors, but when you think about it, the food you're going to buy from the store, unless it's 100% organic, is probably grown with far worse than the dyes of papers on paper. So I always look at it as I have a lot of faith in my microbes that they can break a lot of this stuff down. Most of the ink now is soy-based ink. It's probably, unfortunately, genetically modified soy, but it still can be, even Roundup is broken down by microbes. So if you keep adding organic matter, you will have so many microbes in your soil that they will eat any of this. Worms also have a capacity to detoxify your soil, and no one really knows how this works, but it seems like what happens is that worms can exist in relatively toxic soil. And then after they've been there for a while, the soil is less toxic and no one knows where the toxins go. So again, by putting mulch down, it creates a really nice blanket for these creatures. Like if I was a soil creature exposed to the rain and the wind and the cold and the warm, I probably wouldn't thrive very well. But if I was under a nice blanket that still let some air in and held the moisture in, held a little bit of warmth in, I'd probably thrive more. Yeah, cardboard works really good. Cardboard works really good. I use a lot of cardboard in my garden, and you don't, if you have that cardboard that's glossy, I just leave it out in the rain for a little while. And then what happens is you can actually peel off the plastic layer off the top of it because the cardboard starts to break down. And so you can peel off the plastic layer of it, throw the plastic layer in the garbage, unfortunately, and then use the cardboard underneath. But regular uncoated cardboard also works really, really good. And there's something in the glue of the cardboard is full of nitrogen, actually. And it's actually kind of cool. The worms love gardens that have cardboard in them. So any kind of cover crop will also prevent soil loss and feed the soil, because remember, the roots are in there with all those exudates, so they're feeding the soil, they're feeding the microbes. But also when you look at soil loss, like we work really hard to build up our soil, why would we leave our soil bare to just run off and get lost? And sometimes, you know, the soil loss is kind of almost imperceivable, but still it exists. And it's a shame that we work so hard and lose it. Remember, when you're losing soil, you're also losing nutrients. So this is a graph with bare soil, and you can see all these nutrients are lost, but these are just different types of cover crops. And you can see that the soil loss is actually into the negative. There's another picture that really illustrates this well, and this is an experiment you can do at home. This is a great experiment. I wish I had seen this when my kids had to go to science fair, because this would be a very cool experiment to bring in for science fair, where they just got these 3 jugs and they cut them open and they put soil in all of them. And this is just the bare soil. This is soil with mulch on it. And this is soil where some grass was planted. So you can substitute weeds, you can substitute cover crop, you can substitute any kind of plant. It doesn't matter. And then they watered all 3 of them. Look at the runoff that they collected. So the one that had nothing covering it, no mulch, no plants, that's all runoff. Look at the color of that runoff. That's all soil particles. All that soil that we bought, all that soil that we worked so hard to build, it's running off along with the nutrients. When it's mulched, you can see you still have a little bit here. You still have a little bit of runoff. It's turning the water, you know, slightly tan. When there's plants growing on it, and remember, it doesn't matter if it's weeds or if it's grass or vegetable plants or whatever it is, the runoff is crystal clear. No soil is running off, or imperceptible amounts. So the advantages of cover cropping is that it builds soil health. It holds the nutrients into the soil. It controls erosion because the soil can't run off. And actually, if you intentionally plant a cover crop, it will reduce weeds, because generally it will shade the soil and crowd the weeds out. So shade the soil so weed seeds, even if they germinate, they can't do very well. There's different kinds of cover crops, and this is only a short list, but they all have their advantages and disadvantages. Also, I would look a little bit more thoroughly into cover crops, because there are cover crops for shade, there's cover crops for clay soil, there's cover crops for sandy soil. There's all kinds of cover crops. So a little bit of investigation will, you can determine the right cover crop for your particular situation. But it is a really good way to help your soil. When I first heard about cover crops, I just thought it was sort of a break even kind of proposition where soils would give the plants a bunch of nutrients and then the nutrients would go back into the ground. So it was holding on to the nutrients that were in the soil, but I didn't realize that what's happening is that using a very tiny amount of nutrients, a very tiny amount of nutrients, the plant is building tissue using carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen are actually the main components of any plant. And they're all free. They're all from the air and the water. So really, cover crops are using a tiny amount of nutrients to build a massive amount of organic matter. And so they're really a net gain in organic matter. They're not just a break even, and they're a net gain in nutrients because the nutrients keep building up in it. So there's all different kinds. There's the grains, wheat, rye, sorghum. The best one adapted to here is oats. Oats is a really good cover crop. And then if it does freeze back, but then it creates mulch. There's clover, there's vetch. I really love crimson clover. It's gorgeous and it adds nitrogen as well as biomass. And it competes really well with weeds. And then there's actually even brassicas, and these are often used for really heavy soil. So if you have a heavy soil, clay soil or compacted soil, if you plant, again, daikon radish or some of these other brassicas, they'll help to break up that compaction and add a tremendous amount of biomass as well. And so this is the answer back to someone said about incorporating their broad beans into the soil. And I prefer this method because it's less disruptive to the soil. And what that is sheet mulching cover crops. So rather than tilling them in, it's a good idea to chop them, let them drop right where they are, and then cover them with newspaper or cardboard. Or if you don't like either of those, you can cover them with any kinds of organic matter and then just let it break down. And because it's on the surface of the soil, it's going to break down more effectively. So this is an illustration of sheet mulching. And, if you go on the internet, you can see sheet mulching and you'd think you think you have to be an exact mathematician, scientist to perform sheet mulching because the instructions are so very specific. And it's not that difficult. What the whole thing is whatever is there, weeds or grass or cover crop, you can cut it, you can roll it, and that's what bigger operations do, is they actually just kind of crunch it up. They have like a roller that smashes it up and flattens it, but you don't remove it. You just leave whatever is there. Then you put a little bit of compost or manure on there, and you don't need much. This is the layer where you can put some some compost that's not fully composted. You can put it in that layer. And then it's good to put a weed barrier in so that any of the weed seeds that are in the unfinished compost, which is the other danger of unfinished compost, if you have weed seeds in it, they will grow. But not if you put some sort of weed barrier. And I don't mean weed cloth. What I mean is either the cardboard or newspaper. Use 6 sheets of newspaper if you're going to plant right into the bed. And it has to be at least 6 sheets to shade out the germinating weed seeds, or use 1 sheet of cardboard if you are letting your bed sit, say, over the fall and winter. And then the top part, it's nice to put a little bit of soil on here. If you're growing right away, you will have to put some soil down or some compost down on the top. But if you're doing it in the fall and it's going to sit all winter, then you can just put any kind of mulch on top of that and then just let it sit. And in the spring, you'll be stunned at it, how good the soil is underneath it. So the whole chop and drop thing is like growing your own mulch. So you don't have to buy a lot of things. You don't have to go to the store and buy straw or hay. Nature delivers weeds to our garden on a regular basis, and we can use those to enrich our garden. So I look at weeds as gifts now. And you can do this with all weeds, but the annual weeds work good. Even the perennial weeds, if you keep chopping them and leaving them in place, eventually it exhausts the root. So you just chop them down and use them for mulch. So just remember that microbes need a secure home. So one that's not going to be all dug up and rototilled up. They need food, water, and air. And so if you love and nurture your microbes, you love your soil, and you're going to take really good care of it. You're going to take good care of it, and it's going to take good care of you. Mediterranean soils claiming to impart wonderful flavor and qualities to food. Can we duplicate our work to add flavor? We are actually limited by the original soil. As far as a certain amount of terroir, which is what it seems to be you're talking about, is that terroir, because the minerals in the soil are pretty predominant, no matter how much organic matter we add. The predominant minerals are the minerals in the soil that is already there. That's always going to be predominant, just like you can't change your soil texture. But by adding organic matter, what happens is we can improve the taste of whatever terroir we have, because plants that have grown in an atmosphere of lots of organic matter and had the ability to draw nutrients whenever they wanted to, then they accumulate more carbohydrates in their tissues, and more carbs make it more tasty. Everybody loves carbs, whether we want to eat too many of them or not. But complex carbs are actually good for us. It's the simple carbs that are the real problem. And so by adding organic matter, you will improve the flavor of whatever terroir you're starting with. So are these plants, we are renowned for our terroir? I don't know, but Jane, where exactly are you living? Banfield. I would say whatever plants do really well in your climate. Yeah, promotional. So I would say that it's more than terroir. I would say that it's kind of after gardening on the West Coast, I would say that the vegetables that did best for me and have not done as well any place else were peas, spinach, and cauliflower. A lot of the brassicas, but I've had decent brassicas other places, but never the peas, spinach, and cauliflower that I had on the West Coast. And I would talk more about the cool sea breezes as much as the soil. Cool sea breezes, the minerals from the sea, that sort of thing would be beautiful branding. Everybody wants to be in touch with the ocean. I mean, we've got brine in our bodies, right? So promotional, that would be the branding I would I would really look for. Yeah, and tea from seaweed and horsetail, yeah, would help enhance that for sure. And yeah, I think that this is where a lot of food is going, is not only local. There's always going to be the grassroots people, but if you're selling to people who have a lot of money, they want that story. They want ecologically grown. They want, because that makes them feel good about their purchase, and they want to know the story. So they want to know that you've used, natural weeds to help fertilize. So that's the way I would go. So we have one more presentation, and I'm always so late, but this was the most important part of it, if I can say so, because, really, if you get the soil right, you really have less problems with watering and irrigation, and you have less problems. What did I do? New share, that's what I want. And you have less problems with pests and diseases. So now there we go. So we're going to talk a little bit about pests, because everybody's, where is it? Where is it? Is it? There it is. Because it doesn't happen overnight that you can relieve the stress of all plants. And it doesn't happen overnight that you're going to build up your soil. And it doesn't happen overnight, or it doesn't happen because we as gardeners push the boundaries, right? We want to go grow peppers and tomatoes and eggplant in places that they're uncomfortable. We want to grow lettuce sometimes if we're in a too hot climate. We want to grow lettuce in Port Alberni in the middle of the summer, where it's a bit stressed. We want to grow tomatoes and peppers and Eucalypt where it's going to be a bit stressed. And so we are always dealing with a little bit of plant stress. So how do we manage that? What happens when these critters come along and do what they were evolutionarily designed to do, which is remove some of our plants from the gene pool? What do we do? So these are aphids, and not sure if you know this or not, but aphids give birth to live aphids that are 100% female through successive generations and are already pregnant. So you're not going to get rid of aphids. They are the bottom of the food chain. A lot of things feed on them, and they're meant to proliferate. So what do we do? And these little white flecks here, so many times people send me pictures, they ask me lots of questions, they send me pictures and they say, oh, my plant has whitefly. These little white flecks here are not whitefly. What they are is that aphids shed their skins. They go through instars, so types of metamorphosis, where they're almost like snakes and they shed their skins. So these white shells here, these white flecks here, are actually their skins as they have grown out of their skins and shed them. So you can see a couple of different generations. There's bigger ones, smaller ones, because they're just going to keep reproducing. So what do you do when you see something like this? Well, you can actually, if it's an older leaf, just pick it off. The other thing you can do is you can give it a spray of just plain water. What happens with aphids is they've got a mouth part that is so firmly inserted into the leaf that when you spray them off, it breaks the mouth part off. They can no longer feed after they've been hosed off a plant. So that reduces the population. And here's their mouth part inserted in there. There's a close-up. The other thing we can do is we can plant a lot of predator attractive plants. So we don't have time to go through them all, but any plant that has a lot of tiny flowers, so dill, parsley, Queen Anne's lace, anything like that that has an umbel-shaped flower with lots of tiny flowers on it. Fennel is another one. Will attract this tiny wasp, and what this tiny wasp will do is it will land on the aphid and insert its ovipositor into the aphid's body, lay its eggs inside the aphid's body, and completely, when those eggs hatch, what they will do is they will eat the guts of this aphid for their baby food. And then they'll hatch out and they'll grow and they'll lay more insects. So by attracting some of the natural predators to the area, then you get their help. This is a kale that is encrusted with woolly aphids. Another strategy for somehow mitigating these problems is by growing your own seed. I have kale now that has not been attacked by woolly aphids in years and years and years, because the kale that did get attacked, what I did is I pulled it immediately, ate it, fed it to the chickens, composted it, whatever. I did not tolerate a plant in my garden. So I didn't try to save a weak plant. So the only plants that were left in my garden when it was time to go to seed were sometimes very few, but there's usually at least one that doesn't get attacked. And that's the one that I save for seed. And over the years, I have bred aphid resistant kale. So I'll be happy to send some seeds off to you guys. I think I've shared some on the coast already. Originally, the seeds came from the coast anyway. So part of the whole thing about pest control is to spot the pests quickly so that you can do something, whether it's hose it off or clean off the leaves. And with aphids, what you will find is that the leaves start to get stunted because, of course, they're sucking on them. So they're collapsing cells. Also, because their mouth part is so firmly inserted, the plant sap just gets pushed right out of their body as excrement. And that excrement is sticky and shiny. And what it will do is it will start to feed other organisms. And so if you see the plant is sticky or shiny, you probably have aphids, so you need to look a little closer. This black sooty mold is something that grows on what's called the honeydew, which is aphid excrement, actually. And so watch for things like that. And here's the honeydew. So the aphid is actually, the turgor pressure of the plant is so strong that it pushes the plant sap right through the aphid's body. So it's a bit of a waste. They're kind of sloppy eaters, actually. Here's the mouth part inserted into the cells. So you can see how deeply this mouth part is inserted, and there's no way they're getting those suckers out. So a spray of water is way better than soap, because soap kills an insect by dissolving the waxy coating on the outside of the insect shell. They don't have an endoskeleton like we do. They have an exoskeleton, and that's the outside shell. So safer soap kills by, or any kind of soap, kills by dissolving that waxy cuticle. The trouble is it also dissolves the waxy cuticle that protects the plant from losing water, protects the plant from disease, protects the plant from subsequent attacks, protects the plant from drying out, all kinds of things. So also good to know sort of the life cycle of these aphids. So what can happen is, again, a lot of the time we start from the egg, and then the aphid hatches out, and there's a bunch of aphids that are just reproducing more aphids. So more females, more females, more females, and they call them asexual, but they're actually capable of producing offspring. So I'm going to call them females. And then what happens when they get stressed is they go through a physiological change where a male and a female form can arise or does arise. So what's the stress? Overcrowding is one of the stresses. Winter temperatures or imposing winter, shorter day lengths will cause the male and female, will cause all of a sudden the rise of a winged generation that's both male and female. And so then they go to lay their eggs again. So know that if you see the winged generation, that's when the aphids are going to spread. They have no other ways of spreading. So sometimes I tolerate aphid infestations because I find if I do, it ends up attracting predators. Now, a plant can actually call predators to help it. So a plant that's attacked can actually call ladybugs, can call those little wasps, can call lacewings, can call them on the infrared scale. So it sends off vibrations on the infrared scale, but it needs a lot of energy to do that. And so the first thing I do when a plant is infested is I put compost around the plant to give it more energy. So basically I feed it more carbs. I feed it better. And when I feed it better, it has more energy so that it can call for help. Basically, it sends off a different vibration if it gets that extra energy. You can always also use some soluble organic fertilizer, anything that will feed it a little bit, give it that little bit of a boost so it can call the predators. And it actually works 9 times out of 10, it's worked for me. So instead of having these ongoing generations of aphids, there's the grandmother, the mother, and the baby. Isn't that cute? And it happens very quickly. Also learn to identify some of the predators. It really is important to start to learn which ones are predators and which ones are not. So this guy is a ladybug larva, which actually consumes far more aphids than any adult. The adults are more concerned with eating high nectar foods and mating. The adolescents, which this is an adolescent ladybug, they're more concerned with eating. They just like most adolescents of most species, especially the insect species, any of the larvae are just interested in eating because they have to build up all this energy to pupate, to form this little chrysalis where they will turn into the winged generation. And so they're the eaters. And so you want to attract the larvae of these guys. You want to attract the adults of these guys, but make sure that you know the larvae of these guys so that you don't kill them. Now the adult will eat some aphids, but nowhere near what the adolescent will eat. So here's some of these aphid predators I was talking about before that we can attract to our garden by using these high nectar plants. Remember, it takes a lot of energy for these winged creatures to fly around, so they need that high nectar. So incorporating flowers into your vegetable garden is actually a good strategy, or around the edges, and there's a lot of different ones. Look up insect attractant plants and see. But this little Ophidius, what it does is it lays its eggs. Here's it's inserting its ovipositor into the aphid. And then you will start to see these aphids turn into these little crusty things with holes in their butt, because that's where the hole in their butt is where the little ophidius have hatched out, and they've gone on to predate more aphids. I even had this in my basement grow room. I had ophidius, I overwintered peppers, and I had ophidius that somehow got into my basement grow room, and they laid their eggs in these plants. And then I had all these aphid mummies. Oh, my Siri wants to talk to me. There are all these, I had all these aphid mummies on my pepper leaves, and all the aphids were dead. And I mean, I just ignored them. I just left them because, oh, it was the end of the season and the peppers were old, and I had no idea this was going to happen, but it did. And now the peppers are in my regular greenhouse and they have peppers on them. And the aphids are gone because the ophidius cleaned them up. Aphidoletes is another aphid predator, and it's got a slightly different strategy where it doesn't lay its eggs in the aphid body, but what it does is it actually, the larval stage just is a voracious eater. And the aphidoletes, you can help the aphidoletes to survive in your garden by using mulch again, because it overwinters in mulch. So it will not overwinter in your garden if you don't have leaf litter and mulch in your garden. So even if you can't bear to mulch, have some areas in your garden where they can lay their eggs, you know, like some leaf litter or something piled up in a corner where they can lay their eggs, because they will, and then they'll hatch out, and they will, the larval stage are voracious predators. So this is a close-up of the ophidius, the results of the ophidius, and that's what the aphid will look like. It is no longer alive, as you might guess. Oh, there's another question. Introducing nematodes control bugs, cutworms, or other pests present in the soil. Yeah, that's an okay strategy as well. You know, nematodes will be naturally beneficial. There's all kinds of nematodes, right? There are nematodes that eat the roots of plants as well. They're called root knot nematodes, and the golden nematode will eat the roots of plants. But certainly the stuff that they're selling you are the beneficial nematodes. But nematodes almost magically, beneficial nematodes almost magically appear in soils that have a lot of organic matter in it. So, and I actually have a picture someplace, and I don't think I included it in this presentation, but sometimes I do so many, I lose track, but there's actually a picture of a fungi. I have a picture somewhere of fungi strangling a bad nematode. And so there's all kinds of checks and balances in healthy soil. And it's okay to use these nematodes, these beneficial nematodes, to get going, to sort of short-term fix problems. But long-term, your best strategy is still to build your soil. So here's a problem. Oh man, I hate these guys. And here's a close-up of their face. Cutworms. And Leah Austin was the first one that reported to, this is the first report I had heard of cutworms not only cutting at the surface of the soil, but actually climbing up plants and eating plants higher up on the soil, higher up from the soil. Cutworms look like this. They feed at night, so they're kind of gray and black and slimy looking, a little bit of brown on them. They curl up when they're disturbed, and they feed at night. So for a lot of these creatures actually feed at night. Cutworms, slugs, snails, they feed at night. And so it is really a good strategy to go out at night with a headlamp to look at what is attacking your plants. I feed these to my ducks. Good to save them for chicken feed. This is the moth that they're from. This is the larval or the pupa stage. So they lay eggs, they hatch into the larva. The larva eats like crazy to store up enough energy to pupate. And so if you find these guys in the soil, you know, when you're planting something or digging up weeds, by all means, put them in your bird feeder or feed them to your chickens or your ducks, because they will turn into adults, which will lay more eggs. And then again, the larva or the adolescent stage will eat your plants like crazy. Lots of different kinds of cutworms. My mom used to put little paper collars around the plants so that the cutworms didn't eat through them. So there they used to eat through the tomatoes a lot. And so if you're finding that you do have a lot of cutworms, that might be a strategy to protect some of your other plants. So she used to use toilet paper rolls, paper towel rolls, that sort of thing around the base of the plant. You have to bury it in a little bit, but it's really hard to find them. Usually the damage has started to be done by the time you find them. So that's another reason to, and here's a cutworm that is actually eating an eggplant. So again, to build up your soil, these are cutworms that are attacking grass. Another good strategy is to attract birds to your garden. So here's the life cycle of the cutworm, where you can see they go, they have an active period and a not active period, just like we talked earlier about the flea beetles. And so these guys in January, they're in eggs. In February, they're larvae. So the larva will pretty well stop eating in May. So then they'll back to pupa adults. It's a larva that eats. So another strategy is if you have crops that are continually attacked by cutworm, is to plant them later. By the beginning of June, if you can get away with it, by the beginning of June, the larvae are in the pupal form. So they're not doing any eating, they're hibernating. And, you know, then they'll hatch out as moths and they'll lay their eggs around this time, around July. Yeah, they'll lay their eggs around July and onward. But you haven't got any larvae after that, and the larvae are doing the eating. So if you have a crop that's continually attacked, plant it a little bit later if you can get away with it. Here's an example of a collar, and it will kind of prevent them even from climbing further up the plant in a lot of cases, although not in all cases. Attracting birds to your garden however you can. And I know sometimes it's hard to have bird feeders because they attract bears and that, but if you plant plants that have very small berries that are very high up, a lot of the native plants will attract birds. Look up what plants in your area attract the best birds, because birds love eating larvae, and they will search them out and find them. I mean, chickens, of course, are another thing to allow your chickens in the winter when things are in the egg and the larval stage. Chickens will hunt out and eat the larvae of a lot of these. Fungus gnats are usually only a problem in greenhouses. They're sometimes, they kind of look like fruit flies until you look at them closely. And it's the larva of the fruit fly or the fungus gnat that does the harm. The larva in the soil will actually eat away at the roots. Hi, Leah. Of course, I'm gone over time. Fungus gnat life cycle is also helpful to know, where really their life cycle isn't that long. it's 14 days, 2 weeks. So if you have an infestation and they tend to like overly wet soils. So by keeping your soil reasonably wet, but not overly wet, by not letting water accumulate on the floor of your greenhouse, by not allowing algae buildup, you can prevent fungus gnat damage. And so you can clean it up. And if you clean it up, they probably won't be back if you clean it up. And the ones that are there will die off within a couple of weeks. They also attack mushrooms, so that's a problem. Here's another strategy, and this is just a stiff yellow piece of paper with a little bit of Vaseline on it. You can buy these sticky cards that have a special glue on it, but yellow cardboard, so yellow file folders cut up with Vaseline on it will trap a huge amount of fungus gnats before they lay their eggs. Also, you see this grit on the surface, again, mulch, but this is like a chicken grit, kind of gravelly mulch, and that will discourage them from laying their eggs in the soil. So that's another strategy. You can see how small they are. They're really, really small. There's also a predator mite that you can actually purchase. But they are indigenous as well. So sometimes they will move into big populations. There are nematodes that will kill fungus gnat larvae, and someone mentioned that. This is leaf miner. You really can't do anything about it. Even the most deadly poison will not penetrate the leaf. Other than a systemic poison, which poisons the entire plant, which is not what you want to do on anything you're eating. But the best strategy here is to just pick off the leaf. Just pick, and this affects beets a lot. It affects rhododendrons a lot. Sometimes Swiss chard even, but pick off the leaf and discard it or feed it to your chickens again. So this is leaf miner, and you can see the larva again is doing the eating. It's burrowing into the plant. If you catch it quick enough, you might be able to kill it. But once it gets into deep in the plant, it's really hard to kill. Here it is on the tomato leaf. Sometimes I've seen it on beans as well. Best to just pick off the leaf. The life cycle, you can look at a bit later. This is a predator insect called Cryptolemus, and it will manage to eat a lot of different insects, actually. So if you have a greenhouse or an enclosed space, it might be worthwhile to look at the bug factory to see if you can get some of these guys. Then there's mealybug as well. Mealybug generally is just on houseplants or greenhouse plants. And so it's not available. And here's the Cryptolemus again. Looks a lot like mealybug. So that's where you really have to know your predator from your prey. In this case, the Cryptolemus is also eating aphids. So that's a very cool all-purpose bug. There's a Caloptera larva and adult as well, and they eat insects like crazy. This is scale, usually just in a greenhouse or on houseplants. The best strategy for this is to wipe them off. Huge job sometimes, but other than a systemic pesticide, you can't really get rid of them. Again, you can feed the plant really well to help them resist. Here's the young scale. So watch for this, because if you can catch it when it's this young, and this is true for a lot of insects, is that they tend to hang out underneath the leaves and at the tips of the actively growing plant. Those are the two places that they hang out. So ants, some people will say, well, I see ants on my plants and they're destroying them. Well, ants themselves won't destroy your plants, but what they do is they herd aphids and they herd scale. They move them around to the juiciest part of the plant, and then they milk them like dairy cows for the honeydew once again. There's the life cycle of a scale. And here's our favorite. We can't finish without looking at our favorite. And slugs are not actually an insect, they are a mollusk. And one way to identify what you have is that there's chewing insects and there's sucking insects. So it is good to know which insect is chewing and which one is sucking. So for sucking insects, there's aphids, there's scale, there's mealybug, there's spider mite, there's thrips, which are slightly different, but you won't see big bites out of the plant because they've just stuck their very delicate little mouth part in there and they're just sucking. With sucking insects, what you'll see is distortion as the cells collapse as they're sucking on them. So first thing you should ask yourself, is it a chewing insect or is it a sucking insect? And that will narrow down the insects. But as you can see, slugs can do a tremendous amount of damage. They can eat whole leaves and plants. Usually there's a trail of slime around, so you know who the culprit is, even if you don't see them. This is slugs mating. Slug love. They actually mate in a big glob of slime. And I've seen this in a greenhouse where they drop down and they wrap themselves around each other in this big thing of slime. And there they are. I think the best solution for these guys are ducks. I am convinced Indian runner ducks are the best thing going and will prevent any of this. This is spider mite, sucking insect. Once you see the webs, it has gone way too far. Wash, wash, wash these guys off. Increase the humidity. This is the damage they do. You can see they're just sucking away, leaving all kinds of holes. There are predator mites as well, but the mites that generally attack our plants have 2 spots on their back. And here's the 2 spots, and this is a close-up of these beautiful creatures. Another close-up. And this is the kind of damage, so the spider mites actually collapse the cells on this avocado. Not that you guys are growing avocados, but this is the kind of damage that you'll see because these cells were actually collapsed by them sucking on it. There's a pepper with collapsed cells, an eggplant, and that's a thrip. Oh, back. There's a thrip, and thrips are also sucking insects that leap when you disturb them. Again, they'll probably be mostly in a greenhouse. Oh, going wrong way. They'll cause flower damage. They nest really deep in the flower, and there's the difference between spider mite and thrip damage. That's the size of a thrip, very, very small, next to a grain of salt. And again, they will generally attack stress plants. You can wash them off. You can remove the leaves to reduce the population. They've got little wings, so they kind of fly like leaf hoppers. And there's a pirate bug attacking a thrip, which is one of the biological controls. And there's a mite that's a biological control. And here's the cabbage moth, another one of our favorites. And gypsy moth, all kinds of different moths. Root weevil, please look really closely at the root weevil because there are insects called ground beetles that look almost like this, but have big mandibles. They have big jaws. And so while you're doing your scouting, you don't want to kill ground beetle because it eats slug eggs. The root weevil is another story. There's nematodes to control that. And this is the kind of damage that the root weevil does, leaves things like that. There's the larva. Again, it's the adolescent that causes all the problems, eats the roots of strawberries. And there's the nematode that actually controls them. And there's the mouth part of the nematode. And you can see whether it's a healthy larva or a larva that has been infected with the nematode because it's turned brown. So you know that your nematode application has been successful if you start seeing the larva turn like this. Oop, wrong way. There's also, this is the little baby nematodes hatching out of the larva. Whitefly are generally in greenhouses. That's the underside of the leaf. There's a couple of different kinds of whitefly, but they also have predators. The whitefly is a sucking insect. It causes a collapse of cells. If you have a greenhouse and you want to control whitefly, this is a card that contains Incarcia formosa. Incarcia will predate the whitefly. Once the Incarcia shown here inserting its ovipositor predates the whitefly, it turns black like this, so you know that it's been successful. Delphastus is another bug that will also predate whitefly. Oh, I know I've gone a little bit over. Sorry. I sort of rushed through that. But if anyone has any questions, please feel free to email me. Helene, pass on my email, and you'll get these presentations so that you can look at this stuff more closely. And hopefully you've learned something today. And yeah, thanks for having me.